In this video, we're going to see how to answer some of these questions about vector spaces, such as vector spaces of polynomials and matrices. So here I've got a question about polynomials, namely, are these three polynomials linearly independent? So we approach this in the exact same way as we did for vectors. We want to know how many ways there are to build the zero polynomial out of these three polynomials. In particular, we want to know, is there a non-trivial solution? So is there a non-trivial solution to, I'm not going to use x variables here because we have all these x's floating around. I'll say y1 times 2x squared plus x minus 1 plus y2 times the second one, 3x squared plus x plus 4. And say y3 times x squared plus x minus 6. So is there a non-trivial way to build the zero polynomial out of these three? So to answer this, we want to figure out if the polynomial on the left is equal to the polynomial on the right, the zero polynomial over there. And two polynomials are equal exactly when all their coefficients are equal. So let's go ahead and rewrite what's on the left, but group the things by coefficients. So we can think about expanding out, multiplying y1 times each of these terms, y2 times each of these terms, and y3 times each of these terms, and then grouping by the coefficients. So we'll go ahead and do that in one step for efficiency. So for an x squared, we'll get a 2y1 here. From the middle term, we'll have a 3y2. And from the last term, we'll just have a y3. So those are the only terms that have an x squared in them. For the x's, we'll have a y1 from the first one, a y2 from the second one, and looks like plus y3 from the third one. And finally, for the constant terms, we have a negative y1 plus 4y2 and minus 6y3. And we want to think about solutions of producing the zero polynomial there. So the only way that could be zero is if this first coefficient is 0, the second coefficient is 0, and that third coefficient is 0. So we need these three things to happen simultaneously. 2y1 plus 3y2 plus y3 needs to be 0. y1 plus y2 plus y3 needs to be 0. And negative y1 plus 4y2 minus 6y3 also needs to be 0. So now we have a system of equations, and we're asking ourselves how many solutions this system has. So we can write down a corresponding augmented matrix here. So 2, 3, 1, 0, 1, 1, 1, 0, and negative 1, positive 4, negative 6, and 0. So to answer that, just like we have been doing, we'll compute the reduced row echelon form. I've typed this into Wolfram Alpha in advance for expediency. And this produces 1, 0, 2, 0. We have 0, 1, negative 1, 0. And finally, the bottom row is all zeros. All right, so our question was, is there a non-trivial solution? So we'll always have the trivial solution when y1, y2, and y3 are all 0. But here I see this third column here is a non-pivot column, which means we'll have a free variable. Whenever we have a free variable, that means we have infinitely many solutions. So we have infinitely many non-trivial solutions. Right, there's only one trivial solution, so if I have infinitely many solutions, all but one of those infinitely many things are non-trivial solutions. So we have non-trivial solutions. So the answer to this question is yes. Is there a non-trivial solution? So that means that our polynomials are linearly dependent. No. They are linearly dependent. We can build that third one out of the first two.